All right. I'll go ahead and get sharing.
Yeah, I'll
Let's
just
do.
kind of kick this off here a little bit, Joel, if I can.
Sure.
J.R. Tallman is part of the IBM team. He is the technology sales leader, or one of the technology sales leaders on the IBM account team supporting Elevance Health. And Laura Olin Baker is a sales automation sales manager. That includes HashiCorp. So Laura and I work very, very closely together. Certainly, you know Greg as well. And I guess West, he did this demo, or I guess about a month ago for Shareth and Bhupal and Kieran and a few others. I have that. It's a full-on hour demo. So I'll be happy to share that with y'all if you want to get like right, if you want to see the whole thing from soup to nuts. But for me, I'm just hoping we can have more of like an executive discussion versus going right into the demo. So if you look at the agenda, we're going to have AI-driven executive overview. And so again, right, rather than just getting into the demo, we're going to kind of outline how, like, while AI dramatically accelerates infrastructure delivery, at the same time, it amplifies existing weaknesses in governance and security. So I want to talk about how we address this with like controlled workflow-driven guardrails. And I think that section's important because it kind of establishes why you need to have, these guardrails and maturity in place, or else you can get yourself in a lot of trouble. And then from that perspective, we'll do the actual demo of the MCP server, which will write modules for us. And then want to talk about an AI readiness assessment and just kind of a quick overview. So basically, we have a assessment and a discovery framework, which will evaluate your readiness across 5 different domains. And the output includes like a scored maturity card, like a scorecard, and then we give you a roadmap with concrete deliverables. So we're hoping, based on what you see here today, that that might be the logical next step. But without taking up any more time, I'll just kind of turn it over to Lee. I don't know why I said Wes. I know Wes Fowler, and I got that mental block, but Lee.
Oh, good. Wes is a good name too. I'll be Wes for today. All right. Thanks for that intro, Dean. I appreciate it. Sure. Hey, Joel. My name's Lee, not Wes. I am a solutions architect here at HashiCorp, and I sit at the intersection of our infrastructure lifecycle management product line, which is Packer and Terraform for the most part, Nomad and Waypoint as well, and our AI ambitions and our products and services that we're working on over here. So I have a good sort of 10,000-foot view of where we are in that space, what sort of things that we're seeing in the field from both our customers and just across the industry, and where we want to push forward and help our clients move forward with AI-driven and AI-assisted development that works within their organization and for them with as little risk as possible. So I'm going to go ahead and start sharing a little deck that I have. And let me know when you can see that.
Yep, you're good.
All right. So I'd like to thank you for being here. We're going to talk a little bit today about our AI-driven infrastructure workflows that we've been working on here at HashiCorp. Let's go ahead and jump into it. As we know it today, let's talk about how we see AI-assisted development manifesting in the field. So it's really no secret that AI is coming. In fact, it's already here. And the benefits of AI development are undeniable. You can accelerate your adoption of infrastructure as code by 50, 60, 100% quite easily. These things are fantastic at generating code and will do so at a moment's notice. But there are also a number of risks that come along with that. It's currently a high reward and high risk endeavor. So this slide talks a little bit about some of the risks that we've identified while working with customers in the field. First and foremost are the security risks associated with delegating work to AI agents. If broad or loosely defined permissions are granted to an agent, it can destroy infrastructure accidentally. It can leak secrets. It can sidestep established organizational policy and governance mechanisms. And the impact of any one of these can be pretty catastrophic. Second, we see a lot of this in the field is the existing delivery bottlenecks that teams are already struggling with are exacerbated by the introduction of AI. As you speed up your delivery process, if you already have any bottlenecks in place that haven't been addressed with automation and secure governance around those automations, then those are just going to be more of a burden for your development velocity. You're creating more work for the people who are already overwhelmed. Third, and sort of related to the second point, is that established workflows in organizations weren't really designed for AI velocity and capability. Most organizations have established workflows that were designed for human operators, and the controls associated with those workflows may not be adequate to manage the speed and scale at which AI can operate. And finally, there is a skill gap. Usually we see application teams may not necessarily have infrastructure experience, and platform teams are already overwhelmed with existing demands. So layering AI workflows on top of that without addressing that maturity gap can lead to a lot of risk when AI agents can actually amplify those existing maturity gaps. They don't really come encoded with the institutional knowledge that your team already has, so they can make mistakes or take shortcuts in order to accomplish the goal that they're given. So let's take a look at kind of what those risks look like when they aren't addressed. So here we have a slide that details an actual incident that a customer had as part of their use of AI-driven development. This was a customer that had an issue where their actual production environment was completely deleted by an AI agent. And this actually just occurred last month in March. So this was an incident that, through no fault of Terraform, their entire AWS production estate was destroyed by an AI agent operating with their infrastructure as code without the correct practices and guardrails in place. So it deleted their entire AWS VPC, their instances, databases, and everything. So it was a pretty massive issue at their company, and thankfully they were able to recover that. But that was largely a function of upgrading their support contract with AWS and having a very costly and manual process of manual recovery done in their AWS estate. So let's talk about what went wrong here. First, the agent itself, in this case Claude Code, was given unrestricted write access to their production environments. It could run any Terraform command it wanted to, including destroy, which is the command that it ran to actually delete their infrastructure, their existing production infrastructure. Second, there was no human gate involved when this happened. If there was a knowledgeable operator of AI or of Terraform in this case, if they were presented with the opportunity to approve or deny the change that ended up making this accident come to fruition, they probably would have been able to prevent it, but they were never given that option. Finally, there was no environment isolation. This agent operated directly against production without any sandboxing and no validation of the changes in lower level environments before introducing them to production. So, what can we do to address the gaps that could lead to an incident like this? So we at HashiCorp, we have put together 3 validated workflows. And these are workflows that map to the personas that we most usually find within organizations that work with Terraform code and Terraform services. So that would be the application team, the platform team, and combinations of interactions between platform teams and applications teams. These validated workflows were all engineered in a way that allows you to gain the benefits of AI-driven infrastructure development while attempting to minimize the risks associated with it. So let's talk about these workflows. The first is a self-service consumption workflow, and this is targeted at your application teams. These are the engineers that need to safely create infrastructure associated with their applications. And the goal here is to offer natural language infrastructure provisioning from Terraform modules that are in your organization's private module registry. This workflow enables your application team engineers to literally type out their infrastructure requirements in natural language while still consuming infrastructure modules directly from the private module registry. And those modules. Go ahead.
Sorry, Lee, don't mean to interrupt you. Real quick,
Yeah, absolutely.
Because I remember when I looked at the MCP server when it first came out, the Terraform one, and at that point it did support using the public registry, but it did not yet support private registry. So has that changed? I haven't looked at it recently.
That has changed, yes.
Okay.
As we have iterated on our Terraform MCP server, it's gained more functionality related to your actual organization's Terraform estate. And that includes being able to introspect information about your private module registry, yes.
Gotcha. Awesome.
And so, ideally, all of those modules within your private module registry, they are designed to conform with your existing infrastructure patterns, your security policies, and your governance rules. So that's how this workflow is designed to enable those applications teams to more quickly consume those vetted modules that exist in your module registry, and also do so through natural language, which is really what AI agents are fantastically good at. Let's see, the second workflow that we've been working on is the module authoring workflow, and this is really targeted at your platform teams. So these are the engineers that need to create the infrastructure patterns and modules for later consumption by your other teams within your organization. This workflow enables these platform teams to accelerate the delivery of these golden infrastructure patterns through Terraform modules using a two-phase specification-driven development workflow. Really what it does is it pulls forward that planning and iteration process and separates it from the implementation process. And it takes that workflow that was taking your platform teams usually weeks to produce modules and shrinks it down to days or even hours. We've seen this one in use quite a lot across the industry. The third workflow here is focused on accelerating your module development lifecycle and your module upgrade uplift velocity. So this one typically involves personnel from both teams that we've previously discussed, so the application team and the platform team. It aims to alleviate a common problem that we usually see in the field, wherein platform teams will publish a module and then it becomes actively consumed by your applications teams or other platform teams across your organization. And then the platform team, which produced the module in the first place, needs to upgrade it. They need to change it in some way and produce a new, a higher level version of that module. But the personnel, the teams that have previously consumed that module, they don't know in the first place, they don't know that upgrade has been done. You need some process by which to notify those module consumers that that the module has a new version. And also they rarely have the incentive to perform that upgrade because that involves some level of change that might incur some risk. So this workflow aims to alleviate those two things by using an AI agent to help the module consumer teams to upgrade to the latest versions And then if any breaking changes are involved in that upgrade, it utilizes the capabilities of your existing coding assistants to rectify or remediate those changes or those breaking changes to assist your module consumer teams in upgrading to the latest version. That really enables your organization to maintain that cadence of upgrades and diffusing those upgrades through the through your organization where those modules are consumed. So you can see how all of these validated workflows, what they're really trying to do, their goal is to help you realize the development velocity benefits of AI assisted development while minimizing the risks associated with it.
Hey, Lee.
Okay.
On
Yep.
our last time we were on a call, I heard you say that there's a fourth workflow that's kind of in the beginning stages. Are you able to talk about that at all?
Yeah, absolutely. Let me go back to the slide real quick. So we actually do have a fourth workflow that we're not fully finished with yet, and which works a little bit differently than these other workflows. So these workflows that I've detailed here are focused on production and consumption of HCL code, the code that defines Terraform modules and Terraform infrastructure. We also have a fourth workflow that we're focused on related to Terraform provider development. So a lot of our larger organizations and more mature organizations have teams within them that are responsible for creating internal Terraform providers. And if you have any teams which are focused on that, we do have a workflow coming into this package that will help in the development process for Terraform providers. So Terraform providers are all written in Go. So this is one that functions a little bit differently than these other workflows. But again, it's focused on bringing your development speed, realizing the benefits of increased development velocity, but specifically for Terraform provider development.
Okay.
So, Lee,
I was just going to say, so when we're talking about, when you say validated workflows,
yes,
what's the artifact? What is the workflow? It doesn't seem like that would be anything proprietary, right? It's just here's the steps to go through.
It is an these workflows are an encapsulation and an encoding of the practices and processes that we see most usually used in the field and also delivered against your existing coding assistants. So the workflows are compatible with, if your developers are using GitHub Copilot, they're compatible with that. They are compatible with Claude Code. We're working on compatibility for OpenAI's Codex coding agent. So that's the vector by which they're delivered. They are encodings of capabilities that the AI agent, we're using the extensibility models of the AI agents themselves to create these workflows.
Okay.
And they interact with your existing system. So HCP Terraform, your private module registry therein, and your Git provider, whether that's GitHub or GitLab. They interact with your existing change management workflows and your systems of record like HCP Terraform.
Okay.
Dean, did you have anything?
Yeah, I mean, ultimately, I think that focus right there is for somebody writing custom providers. Is there thought of extending this to like the provider for Azure or AWS or GCP?
So those providers already exist. If you're writing your custom provider, if you have the need for an internal provider that doesn't already exist within our public like provider registry, then you could use the upcoming provider development workflow to assist in that. And also, if you are, if you have the capability to like fork an existing provider, it could be used to help you create capabilities within an existing provider that might not necessarily exist yet.
Okay, great. Yeah, I'll table that for now. Thank you.
Mm-hmm. Absolutely. Okay, so what are the sort of components that enable these validated workflows to do what they do. So this slide shows some of the guardrails that our workflows implement in order to be successful. And these are really the key components and processes and building blocks that enable that. So firstly, the private module registry, that is the core enabler for all of the workflows that we've detailed. It becomes the source of truth and the system of record that your agents draw from when producing and consuming infrastructure modules. Human approval provides the decision gates that tie into both your standard change management process with your Git providers, but also during the agentic development process as well. And I think we might get to that during the demo as well. Policy as code validation means that any infrastructure code that the agent produces must conform to your organizational security policies and governance rules. And finally, automated cost estimations and quality scoring are included in every module consumer deployment, meaning that your developers get a sense of the impact of their changes before they even make it to a sandboxed deployment.
So for the policy validation, we utilize OPA instead of Sentinel currently. Mm-hmm. Is that something that's supported, or is that Sentinel only?
It is supported. It's supported, and we leverage it. So right now, and you'll see this in the next slide, the architecture that we propose for utilizing these AI-driven workflows is such that we suggest an independent project within your Terraform estate, and that project can have your Sentinel policies associated with it at either the project level or at the independent workspace level. And so every change set that the agent produces, when it validates that change set by creating an ephemeral HCP Terraform workspace, that Sentinel policy set will run against it. So it's forced to conform to those Sentinel policies, or I'm sorry, your OPA policies.
Gotcha.
Yep. And later on, I don't know if you've been clued in, but we are actually working on HCL-based policy language too, which would really accelerate your developers' encoding of your organizational policies to something that aligns to your provider schemas. So when that comes down, when that's released, I think it's in alpha or beta right now, we will support development of policy as well. But right now, we are leveraging the fact that your policies exist and that they can be tied to an ephemeral environment where the agent validates its change set. Okay. So I won't spend too much time on this slide, but this just shows a bit about our recommendation with regards to the high-level architecture around how AI-driven infrastructure development should be applied. The desire here is to fit into your existing architecture related to how you currently manage introduction of code changes, deploy your infrastructure to cloud accounts through Terraform workspaces, and how you already separate logical and physical environments, but to extend that with an isolated environment where these AI agents can safely operate and iterate, while trusting that they can't accidentally introduce changes to your existing higher level environments, extract or use credentials which they shouldn't have access to, excuse me, or circumvent existing guardrails.
Okay.
So on this diagram, you'll see that, usually organizations will have some sort of lower level environments like dev or UAT and staging, and then they'll have their production environments. Excuse me. And these are usually tied to HCP Terraform workspaces and deployed through those workspaces through an HCP Terraform run into the accounts which actually contain the physical infrastructure as it's deployed. And this is sort of your pre-existing architecture. What we propose is that you leverage the functionality that you already have in place, but create an isolated environments where AI agents can generate infrastructure and validate that infrastructure before ever introducing any changes into your even into your lower level environments. So this would be AI agents working against a feature branch of your Git repos, which contain your infrastructure code, and that feature branch will then be tied to a HCP Terraform sandbox workspace, which has its own dedicated HCP team token assigned to it, such that it doesn't have any access. That token, which authorizes the AI agent to actually create the sandbox workspace and plan a Terraform run in that workspace, does not have any permissions outside of the project which encapsulates those sandbox workspaces. And then that sandbox workspace will do a run, and that infrastructure gets deployed to an independent sandbox cloud account. And after changes are validated and approved by a human, then those infrastructure, the physical infrastructure associated with that change set is automatically cleaned up. So you don't have long-lived infrastructure related to experimentation or validation of changes sitting around forever. We also recommend leveraging dynamic credentials for authorizing infrastructure to be created on your cloud service provider, and those credentials can be tied down to one specific that sandbox account where your agents are validating their infrastructure changes against. All right. Any questions here on this?
Nope. That looks good.
All right. So before we head on to talking about the AI readiness assessment, I did want to give a quick demo of the module consumer workflow that we spoke about. This is the one that your applications teams would be interfacing with. So let me change what I'm sharing. All right. So let's take a look. I have a Git repository here, and this is a bare Git repository, which includes the artifacts that enable the workflows to work within the AI coding assistants that we support right now. So again, those are VS Code Copilot and Claude Code. We have validated the workflows against both of those. And we are, again, working on support for OpenAI Codex as well. So I have this Git repository. This is the remote version, and then I have the local version open in VS Code over here. I've gone ahead and logged into GitHub Copilot, which we'll be using to demo today. And I've selected my model. So this repository doesn't include any infrastructure whatsoever. There's no Terraform files. It just has the files that are necessary to enable and encode the workflows themselves. So to get started with the module consumer workflow, imagine I'm an application developer and I'm just sitting here, in my IDE. I'm going to boot up my agent of choice, and I'm going to type TF consumer plan. And that's going to instruct the agent that I want to use the module consumer workflow and start with the plan phase of that workflow. I'm going to copy my prompt that I have prepared over here. So usually application developers, they might not necessarily have or desire to have the knowledge around creating infrastructure. They just want to write their application, but they know it needs infrastructure to run on the cloud or wherever it's deployed and to be served to their desired end users. So they might know what they want, but not necessarily how to write that in Terraform. AI agents are very, very good at translating natural language into code. So we're going to leverage that here. I'm going to paste in my prompt, and my prompt says, I want to create an AWS S3 bucket to store some static content. I want to create a CloudFront distribution with origin access identity so that the S3 bucket is not publicly accessible. I want to enable CloudWatch metrics and alarms to monitor usage and basic health. And I want to add a simple static test page for verification and validation only. Because the agent that I'm using, there is a Terraform token in the environment, it's going to use that Terraform token to authorize access to our Terraform estate. I'm going to tell it to use a specific organization, excuse me, in a specific project within it, so that when it goes ahead and creates that ephemeral workspace, which we talked about, it will do so in there.
Okay.
All right. So it's going to take that prompt. It is going to run the workflow that is described by this TF consumer plan skill that we provided to it. And these are primitives. It's going to utilize primitives that are supported across our supported coding assistants. All right. Okay, so excuse the demo demons. I need to set my Terraform token, which I will do real quick. Let's see.
Yeah. Sorry, Shawn's still stuck on his other call. He's trying to get over here.
Okay. Well, excellent. I can work through my live demo demons while he's getting over here. Okay. All right. Let's see if we can do it now. We'll just resume that session. Make sure that's set.
So on your PC, that MCP server is just running a Docker container, isn't that right?
It is. So everything we have, everything you're seeing here, we have this dev container description here in the repository.
Mm-hmm.
Excuse me. I have some allergies today. In that dev container, when you open the repository in VS Code, excuse me, that dev container starts running, and everything in here loads into the agent, the coding agent that you boot up. So right here in MCP.json, you can see that we actually leverage two different MCP servers. Here's our Terraform MCP server that HashiCorp owns and maintains. And we're just providing instructions for how the AI agent boots up that MCP server and interfaces with it. The important part here is that we are enabling TF operations, which makes it which gives the agent write capabilities to our Terraform tenant. But also we are leveraging a third-party MCP server too, which is the AWS documentation MCP server. And this AWS documentation MCP server is one of the things that AWS maintains, and it's used for agents to just get more context and more information about AWS primitives, instances, whatever it needs information about. So we do leverage that as well.
Okay.
Let's see here. Let's resume that. And we will go ahead and run our prompt again and see if we can get a little bit further. I need my GitHub token as well. Yeah, just need my GitHub token, and we can give it that. All right, so it needed access to a couple of different environment variables that I just didn't set up beforehand, that being the TFE token in order to authorize API calls against our TFE, our HashiCorp cloud platform Terraform instance, and also the GitHub token that it uses to interface with GitHub, because what it's actually going to do is track its work against our system of record of the code base. In the remote Git repo, it's actually going to open up Git issues to track its work. And then when it's done with its, when it's validated the changes and made sure that they deploy correctly and that they pass Sentinel policies or OPA policies, anything which is set on that ephemeral project, I'm sorry, the project that the ephemeral workspace is created in, it's going to open up a pull request, which provides that human gate to introducing changes into higher level environments. So it's going to do some planning process. It's going to ask me some questions to reduce ambiguity. So I provided it with a prompt and I gave it, a good amount of information about what I wanted to create, just using natural language. And it's going to take that and it's going to say, hey, there's maybe a little bit of ambiguity here that I'd like to reduce. So it's going to interact with me, the user, to reduce that ambiguity by asking me questions. Let's say, what project name should I use for this consumer feature and GitHub issue? We will go with its recommendation, which is static site CloudFront, and that's going to control the GitHub issue and the feature branch name, which it's just going to work off of.
Okay.
It's going to move through this process, continuing to gather information from me, the user, until it feels like it has reduced ambiguity enough that it can go ahead and begin writing Terraform code. And in doing so, it will present us with a prompt that we can run to move on to the second phase of the workflow, which is the implementation phase. And right now we are in the plan phase, which we told the agent to start on. So it's going to ask me if it wants to, I think, write a file here. Yep. And it is going to write this, and this is going to be the content of our GitHub issue. And the reason we instruct the agent to work this way is that, the agent is, writing code, and the system of record for your code is the remote Git repositories, which contain the code base. Doing so by creating GitHub issues and pull requests, we do provide sort of a meta contextual layer for interactions between humans and the agentic development process, but also something that can be referenced in the future for more context in future development sessions as necessary.
So is it at this point too, I guess it's not module, but I mean, from here, you could also make sure it's only going to be using from the private registry, right? Because if you're the application persona, that's what we would want.
Yes, it is instructed to only use modules from the private module registry. And that's the mechanism by which we force it to conform to your organization's established patterns. If the private module registry is the place where you put your golden patterns and the modules which you expect all of your consumers to pull from, then this is the way we force it to do that.
Okay.
Let's see here.
The other thing I'm wondering about is if we've got OPA policies. So one of the things that we're also knee deep in the middle of is, and Dean knows this better than most, way back in time before I even joined, a lot of the module development was done using these thin wrapper, what I call thin wrapper modules, right? It's like a single resource module, which is a complete anti-pattern. It does nothing useful most of the time.
Yeah.
There's a lot of those, but it was one of the guardrails that was put into place so that people just didn't go build whatever, however. So they put all these guardrails in the modules instead of where I feel it should have been is either OPA or Sentinel. That's your policy engine. That's where that stuff should have gone.
Right.
So we're moving a lot of rules over to OPA.
Okay.
So what I'm wondering is at this stage of the process, it would also be helpful to interact with those OPA policies and even some Sentinel policies, to where somebody gets a heads up before they get an error?
Yes. So
you know what I mean?
Yeah. When we get the ability to have what we're calling Terraform policy, which is policy as code but written in HCL, the same language that the infrastructure as code is written in. I do believe we'll have the ability to evaluate um, evaluate the policy against the code locally before it even gets to the workspace level. Right now, these workflows are going to leverage policy as code that is established either at the project level or the individual workspace level in the sandbox project that exists in HCP Terraform.
Okay.
Yep.
Yeah, but you see what I mean? You're shifting that left,
Yeah,
so they
shifting
get
it
the
left
error quicker.
before you even get to the remote Git repository, before you even do a Git push. Yeah. Yeah. We want to continue doing that. That's the reason policy exists in HCP Terraform, and as far left as we can get that, the better.
Okay.
Yeah, I can provide a little bit of context there because I've actually been out doing a lot of stuff with TF policy alpha, and then now the private beta. And yeah, I mean, as part of it currently, there it has its own kind of executable engine that you could be utilizing it for doing policy stuff, like you said, kind of shifting it left and doing it beforehand. So obviously it's still not yet out in fruition, and I know that. Elevance is a big OPA shop, but it might be something worth considering when it's available.
Yeah.
So why go that route instead of, because now you guys are going to have OPA, Sentinel, Terraform policy. Why not just kind of settle on one of those policy engines?
I think the goal is, and I'm not on the development team responsible for this, but I think the goal is to standardize on TF policy because it is attached to the provider schema. So actually, the provider developers could write policies which can then be consumed by module developers. They wouldn't necessarily have to write their own policies. They could consume policies which are at the provider level. And also they are written against the provider schema, so they can be linted and do static checking before evaluation, since they have something to be evaluated against.
Okay.
Whereas OPA and Sentinel, you need to have a Terraform plan. You need to know what the result of your infrastructure would look like before their correctness can be validated. With TF policy, because they have a schema and can have a linter associated with them, you could validate their correctness at development time.
Okay.
All right, so our agent's chugging along. I am running it on high thinking mode, so it is taking a little bit longer to do each of the steps. Let's see, it's moving on to creating a GitHub issue and feature branch. We should see that here pretty shortly.
And was all of this same demo the same content that was given, say, a month ago to some of the other team members?
Yes, this is the same demo. I used, when I gave that to your your ICs, I gave that demo using Claude Code. So the only difference in that demo and this demo will be the agent that you see, doing this workflow. But it is also the same. It's the same workflow and the same content as well.
Got it.
All right, so it has gone ahead and created our GitHub issue in the remote Git repository. This includes some information about the change that we want to introduce into this code base, as well as what phase the workflow is in. It has also, yep, it's right. It's asking now for using the private module registry in this specific organization, which I told it about. Yep, and I can tell it discover the best fit modules. I believe it has also gone ahead and created its feature branch as well. Yes, it has 014 static site CloudFront. So it's working on an isolated branch within our remote repository. Yes, we want to create a new workspace in this project using the dynamic credentials, and we'll tell it to deploy to US East 1. So I've gone ahead and I've set up a project in HCP Terraform, which is isolated from all of my other projects. The token that I have authorized the agent to use should have only permissions to do read and write operations in that specific project for workspaces. It's asking me about what security defaults should I lock into the design. I'll take its recommendation. And those dynamic credentials means that when the infrastructure is actually provisioned into our cloud environment, it's not even the agent handling that actual deployment process. It's our pre-existing trust relationship between HCP Terraform and AWS, which is enabling that authorization to create infrastructure on AWS.
Okay.
I'm going to take his recommendation for this question it's asking me again. And as it's doing this work, it's actually using scripts that we have defined in this repository as well. So all of the artifacts that enable this workflow and that the agent is undertaking actions with are contained within this this like base Git repository, which we're using to create and encode the workflows in. And the goal here is actually to enable, if you were to adopt this, customization to your specific organization. If you have a different template that you want to use for your GitHub issues that it creates, perfectly fine. The template is in this repository. All it needs to do is just be edited. If you want to involve intermediate steps, which we don't encode already in the base encoding of the workflow, then that is perfectly fine as well. It's using the existing extensibility mechanisms of these agents, and we have lots of capability and capacity to help your teams customize it to your specific organization's requirements.
Okay.
It's actually doing some parallel work here. We're using sub-agents to do some parallel work and concurrent work within the workflow. If you're familiar, if you've used coding agents before, they have a thing called their context window, and that context window controls, it's like basically their short-term memory.
Mm-hmm.
And as that context window fills up, their short-term memory sort of degrades. So we invoke mechanisms to make sure that we isolate independent portions of the workflow into sub-agents so that the parent agent context window doesn't fill up. Wherever we can use concurrency and parallelization, we do.
Have you run into that still? I mean, because I know those windows have gotten quite a bit larger than they used to be.
Yes. So generally, it has improved a lot. In my specific, anecdotal experience,
Mhm.
I said I started using Claude Code in about July of last year, and that was when like Sonnet 3.5 and Opus 3.0 were out, and it was very important back then to make sure that you were managing your context window very thoughtfully. By you have to understand the tool itself to know how to do that. Um, the context windows have got larger, so it's less of an issue up front than it was back then, and also it's like a triple effect. The context windows themselves have become larger, so it's less of an outright issue. The underlying models have become smarter, so they don't waste as much time and they don't use as many tokens to get from point A to point Z that they did in the past. So your context usage is smaller for the same like capability. And then also when the context window fills up in these coding agents, most of them, all of them at this point, have the capability to undergo what's called compaction, which is where they'll take their context, everything that's in the context window, and they'll summarize it, and they'll write that summary to the new context window. And that compaction process used to be very bad. It was the agent would forget things that happened in your previous context window just because a summary is a summary. It doesn't have all of the information that the content that it was summarizing has. So they would forget things that happened in the previous context window, which were important to remember. That compaction process has become a lot better in my experience.
Okay.
So it's still important to manage your context window, and especially if you're doing long running workflows that you want to be completed at a high quality, and you understand how agents work and how context windows are managed, then you can go ahead. You can still involve yourself in what we call context management or context engineering, which is exactly what we're doing here. We're separating out portions of the workflow into subagents and allowing those subagents to do a thing and then return a minimal amount of context back to the parent agent, so that the parent agent doesn't necessarily need to go do that process itself. It can delegate to subagents.
Okay.
All right.
I know we've got about 5 minutes left, and I do have a hard stop at 3. I've got to run my own team meeting, so I can't be late for that. You've
seen what this is going to do. What it's going to do during this plan phase is it's going to go out to our Terraform private module registry. It's going to find the private modules that are responsible for creating the infrastructure, which I described in natural language. And it's going to create a plan. And the second phase of this workflow is it's going to take that plan and it's going to create a change set, a Terraform module. That Terraform module is going to be created. It's going to go through a run in an ephemeral workspace. Here's the plan that it wants to go ahead and write. And then once that run is successful, like maybe it introduced a typo or something, and it does the run, and it sees the run failed because of the typo. These agents are very good at understanding their verification and validation mechanisms, so we'll fix that error. We'll jump back in here to the presentation, because I do want to go over how this is delivered into an organization and how we see this being delivered. So what we would like to do is work with your company to do an AI readiness assessment. And we see this as necessary because if you remember at the start of my presentation, I spoke about how if you have existing gaps in your maturity related to infrastructure as code management, and the workflows and processes related to that, agents will actually exacerbate those. So we do want to go into an organization and make sure that those gaps are identified and addressed before we go ahead and implement agentic workflows. And the reason we do so is because we don't want to see this happen again. Like this is pretty much worst case scenario for any organization is having something automated with capabilities which are maybe less well understood by their operators go out and delete your production your production environment. So we would like to do an AI readiness assessment, and this will involve a couple of maybe 2 to 4 hour workshops with some of our resident architects or resident engineers, which will come in and evaluate your level of IAC maturity and AI maturity in order for us to identify any gaps that we might need to remediate before we move forward with this transformation initiative, which is usually how this is packaged. And then afterwards, after that AI assessment is done, you'll get a report that goes over those gaps, an artifact that you can review. And then should you choose to move forward, we do package this as a transformation initiative, which comes with our resident services, which are, I think you actually have some in your organization already, engineers or architects who are trained and have the capability and capacity to implement this in your organization's environment, customize it to your organization's particular needs, and get this to be a successful implementation of the what we're calling AI-driven development or AI-driven infrastructure development.
Okay.
And Joel, I'm not sure if you're aware, right, but Ed Mackos, the managing director, IBM managing director, and he set aside $1 million in residency funds for Elevance Health in advance of this renewal. And these services are designed to optimize how your go forward architecture. So it's not something you would have to go out and procure. The IBM team has already set aside those funds for your team.
Okay. So on average, I mean, how much of those funds are going to get used as a result of this particular transformation package?
Yeah, I mean, we've just gotten those funds allocated, and now we're kind of trying to work through and figure out how we're going to allocate the hours. I mean, one of the questions that I have is the focus here going to be around, AWS Next Gen? Is the focus going to be on the 900 plus modules that exist today? We need some of your guidance on where we should spend our efforts, right?
Yeah.
And from that, we need direction from Shawn and team as to where y'all want us to focus.
Okay. And I think it's going to be a combination of the two, right? Because we're already in the process of reducing our module count.
Mm-hmm.
We're trying to not add to the problem,
right?
And start to consolidate. But since there are so many out there and a lot of them are used, I can't just start whacking them and get rid of them because people are relying on those. So I have to take the slow pain of deprecating and then no more updates and yada, yada, yada.
Absolutely.
So we're going through that process right now.
And I guess my comment would be, just analogous to the current module design. If we had our, enterprise architects on the front end of this, providing some guidance, I think we would have had a better outcome. And so now as we're getting ready to embark on this AI journey, we'd like to do the same. So
that would have been 7 years ago, Dean.
I know. It's before. Nobody who made those decisions still works here, but that's why the assessment. We just really hoping that you all embrace that and get in bed with us and go down that path.
Yeah, sure. I think this will give you a lot more visibility into like what it's going to take to actually have a successful implementation of this.
Will you share these slides, Lee? Just I want
will
to make sure that Shawn has a chance to review these too.
Certainly. I'll send those right after this.
Awesome. Well, I appreciate the time, and I hate to bounce abruptly, but I got to go start my team meeting.
Thank you so much for your time.
Let me know how I can share all this content, including the recorded sessions.
Okay, you shoot it. If I can, try to shoot it over to me, and we'll make sure that folks get it.
We'll need a file share or something to.
Okay.
Yeah, the recording. Every time I try to send a recording over email, it's just too big.
Okay. All right. Perfect. Thanks, guys.
All right. Thanks, everybody.
Thank you.
Appreciate your time. Bye-bye.